Hi class, so today I'd like to cover the car loan worksheet, which is on page 9 of the worksheets. So the car loan worksheet is giving us a scenario where we're looking at buying a Volkswagen Jetta for $17,254.38. We're able to put down $2,254.38 of our savings onto it, so that leaves us $15,000 to borrow, right? So the auto dealership is able to get us a loan from a bank for 5 years at 6%, which you agree to sign. And we're asked what will be your fixed monthly payment, right? So the periodic payment function is what we're going to look at here, which has the following inputs, right? So you can see from the table we have inputs of principal, APR, the number of periods in 1 year, and the number of years of the loan, right? So then the output, right, what we'd be given as an output would be the periodic payment. So so we input these items into Excel and we get out the output, which is what we want to know, right? We want to know what the payment will be, the monthly payment, right? So we're gonna it says here we're gonna create the following spreadsheet, right? And I have this spreadsheet downloaded onto Canvas underneath this lesson, and on the right I already have the file open for us, right? But before I get there, I just want to go over a few things, right? So the way this function is written currently, the payment function, is written how we would do it by hand or algebraically. But when we input things into Excel, we can't have things over top of one another, right? It's like entering in a calculator. It has to be a single strand of typing, right? So what I want to do is take this formula and convert it into how we would end up typing it, right? So I'm going to type here above where it says car loan. So the way we would end up typing this is we would have the payment equals, right? And then you would have parenthesis P, and then remember in Excel we use the asterisk for times, right? So you'd have asterisk, and then APR divided by N, and then close parenthesis divided by parenthesis 1 minus parenthesis 1 plus APR divided by N, close parenthesis, and then for exponent we use a caret key, right? So this symbol, so you'd hit the caret key, and then open parenthesis, negative N, and then asterisk for times, right? Negative N times T, right? And then we need to close two parentheses, right? So let me make this a little bigger for you. Right? So this would be how you would enter this into Excel, right? It's converting that formula into a single strand formula, right? And the important thing for making that conversion is you have to know order of operations, right? So this is probably something that you've done a lot throughout your mathematics career, and something that we're going to talk about on the next page, right? Just a refresher, right? And just caution, right? So I would probably write down this formula, maybe both ways, and write it down like on an index card just to have for reference. That will be helpful for you. I will allow you to have in a three by five index card where you can put down important equations or facts that you think you need for the exams, and you can use that during your test, right? So you don't necessarily have to memorize like this formula. This formula is pretty involved, right? Might be hard to memorize, but you can have that as a reference, right? But you want to make sure you know how to use it and what each piece means and so forth. Right? Right, so here it says caution when entering formulas into Excel, you must use the order of operations, right? So you may have remember this as please excuse my dear Aunt Sally, right? Or maybe PEMDAS, right? Which is number 5 is helping remind us of those, right? That's a traditional mnemonic device to help remember the order of operations, right? That's how I remember. Um, re- that's how I remember learning order of operations at one time. So step one, right? Parentheses. It says everything entered in parentheses will be computed first, right? So when in doubt, use parentheses, especially for the numerator and denominators of fractions, right? That's key, right? So when I converted that function, the payment function, into like an Excel-friendly format, that was one thing that I had to keep in mind, right? So it says here, parentheses are like vitamin C. Too much won't hurt you. You just have to use the rest room a lot, right? But too little, and your formula will get gangrene and rot, right? So I'm guessing the author's trying to make some jokes there, right? To lighten the mood. So it's kind of, you might find that entertaining. So then number two, it's telling us the exponents are next, right? So after we evaluate parentheses, now we're going to do exponents. But it's reminding us that when we want to enter in exponents into Excel, right, we use this caret symbol, which you can get if you hold down Shift and the number 6 on your keyboard, right, to get that symbol. And then also, if you have a complicated exponent that you want to put in, so for example, our exponent was a negative number times another number. I put parentheses around that, right? Parentheses around the negative n times t, right? Which you can see here, right? These parentheses around negative n times t, right? It's actually, oops. Right, so it's important to have that. So also here, like you have a fractional exponent, that's another reason why you want to put parentheses around it, right? If you have difficulty, right, knowing when to put parentheses or not around the exponent, you can just do it every time, right? Just as number one states. So number three, right, multiplication and division, right, these are tied, right? So that's one thing you want to remember, is that multiplication are tied. They just compute left to right, right? It doesn't matter which one comes first. Excel just goes through and says, oh, this is division, this is multiplication, right? Just do it in order left to right. And then lastly, addition and subtraction are evaluated the same way, right? They're also tied and just computed left to right, right? So here's an example. So if we have equals 3 times 5 minus 2, right? This would give us 13, right? So let me grab my pen here and show you how that's calculated. All right. So for part A, right, we can see how we get 13 here, right? So the first operation that we would do would be the times, right? That's what comes first in the order. So 3 times 5 minus 2 would become 15 minus 2, right? Because we would take 3 times 5. So then 15 minus 2 gives me the 13, right? So that's what we would do first, right? So for part B, though, what you would end up doing first is the parentheses. So 5 minus 2, right? So since there's parentheses around that, we would take 3 times, and then 5 minus 2 is 3, right? So 3 times 3 is 9, right? And then lastly, part C, right, we have 5 plus 2 times 3, right? So what we would end up doing first is 2 times 3, right? Because multiplication, we do that before we would do addition, right? So this becomes 5 plus, and then 2 times 3 is 6, so 5 plus 6 is 11, right? So whenever you get down to one operation, you just do that operation, right? So this just gives an order of um, of of evaluating expressions, right? So then number 1 says evaluate the following, right? So we have equals 2 minus 6 divided by 4 plus 2, right? So you want to be able to identify what operation you need to do first, right? So I'll show that by highlighting, right? So what we would do first is division, right? So that would give me, so 2 minus, so 6 divided by 4 is what, 1.5, so I'd have 2 minus 1.5 plus 2, right? So then next, the operation I would do, so I have subtraction and I have addition. So remember, here on number 4, we do those in order, they're tied. We just do it left to right, right? So first I need to take the 2 minus the 5, right? Do this first. So 2 minus 1.5 is 1/2, right? 0.5, and then I still have the plus 2. So then 0.5 plus 2 is 2.5, right? So that's just a refresher into order of operations, because we need to be able to use these skills when we input formulas in Excel, right? It's so important to be able to do that correctly. So then number 2 says what formula is in cell E2, right? So if we look here in Excel, let me zoom in a little bit for now. We're talking about this cell here, right? E2. So you can already see that they already gave us the formula for this. But let's approach it as, what would I enter in if I didn't already know the solution, right? So we need to use this. All right, so let me copy this note and I'll paste it down here, so we have that as reference. All right. So in order to get, notice also that in cell E2, what this is doing, right? It's understood that it's calculating the payment, right, of the cell A2, B2, C2, and D2, right? These are my inputs. So A2 is the principal I'm inputting, B2 is the APR I'm inputting, C is the N I'm inputting, and D2 is the time that I'm inputting, right? So when you have a table like this, it's understood that those are the values I'm inputting, and what's in the yellow box E2 is my output, right? So I'm going to want the input function in here, right? So again, I always start all my formulas with equals in Excel, right? So I would do equals, and then we would have open parenthesis, and then notice here I want to take the principal, right? So my principal is in cell A2, so I would have cell A2, and then times, so an asterisk, and then I want to multiply that times the APR, which is B2, right? And then divided by N, which is C2, right? And then I would have close the parenthesis, and then divided by, and then open parenthesis, 1 minus parenthesis, 1 plus, and then my APR, so my APR is B2, so I'd have B2, and then divided by, which is N, so that's C2, right? Close the parenthesis, and then we'd have a caret key, right, for an exponent, and then open parenthesis, negative C2, right, negative N, which is C2, and then asterisk for times, and then T, which is D2, and then we need to close two parentheses, right? So that's exactly the formula that's provided for us on screen, right? And that's how we would write it, right? So if you read up here in the formula bar, right, you can see that formula. Right. So then question 3 says, in the 10 by 6 table, what are the two inputs, the variables for each of the 60 monthly payments outputs? Note, assume the principal, $15,000, and the number of months in 1 year, 12, are both fixed constants. Right? So we want to know that we want to know what are the two inputs. Right? So what we're doing is looking at this table here, right? Where it says table showing monthly payments for different APRs and terms, right? And the question is, what are the inputs, right? So the inputs, when you have a table as showing a function, right? Your inputs are what's on the column and the rows, right? So along the rows, right, are labeled as APR, so that's one input, and then along the columns, those are labeled as time in years, right? So those are my two inputs. So for 3, my inputs would be APR and my term, right? Which we could be more specific, number of years. Right? Good. So number 4 says, what are the two specific numeric inputs for the monthly payment in cell G12, right? So for cell G12, that's here, right, where my cursor is. So that's in the 6% row, right? So we would write that down, 6%, and it's in the 5-year column, right? So this would be and 5 years. Right? So for that specific box, right, these would be the two inputs, and the output would be whatever value is showing in that box, right? Whatever value Excel is showing in that box, in that table. Right? So then going down to question 5, so it says, what are the two specific numeric inputs and associated cell references for the formula in C7? Which of these should vary as we fill the formula down, right? So we're thinking about inputting a formula in C7, right? So what are the two specific numeric inputs, right? So the two specific inputs for C7 would be 1% and 1 year, right? These are my inputs. Then it asks also, what are their associated cell references? So 1% is in B7, and the 1 year is in C6, right? Right. So as we fill down, it's asking what should vary, right? So if I want to put a formula in here and I want to pull this down, what should vary? So what should vary are the APRs, right? Because when I pull this down, I want the APRs to follow down with me, right? So like in this box here, I want to use 4%, not the 1%, right? So I want that to fill down as we fill the formula down, right? So that would be the answer for that last question. So we could say the 1% should change. Right. So number 6 says, what formula is in cell C7, right? Or in other words, what formula should we put in C7? So again, I'm going to reference this equation, right, in order to put that in, right? Because I want this to be the payment function, right? That's my output. So we would do equals, and then remember how to do absolute and references that we've been talking about. So the very first variable is P, payment. So what I would do is why not use this box here, the 15,000 in cell A2, instead of having to type that in, right? Because then what happens if, maybe suddenly you need to change this amount, then you'd have to change that number everywhere, right? So again, cell referencing is key for using Excel, the power of Excel. Or maybe you're making this for your job, and the principal is going to change by your client and so forth, right? So being able to cell reference makes your life a whole lot easier. So instead of typing in the principal number 15,000, right, I would reference the cell I'm going to use to input that, which is cell A2. So I would do $A $2, right? Remember, this is called an absolute cell reference. And you want to do an absolute cell reference here because I don't want this box to ever vary, ever change, right? It's going to be one fixed box, right? That's going to have that information in it. And then we would do times, right, an asterisk, and then the APR, which is in B7, right? And I'm going to want to put a $sign in front of the B, right? And how you want to think about that is when I'm going to want to put one formula in here to pull up and down and to the right, right? Just like we did the multiplication table in a previous video. So when I pull this across, I'm not going to want the B column to change, right? All my APRs are in B, right? So I don't want that to ever change the column, so I need to lock that in. And then we would have divided by, and then I would do an absolute cell reference to C2, right, for N. So I would do $C, $2, right? So that's for N. Then we need to close a parenthesis and then divide by, right, parenthesis 1 minus, parenthesis 1 plus, and then I need to put in the APR, right? So the APR was $B7, right? $B7, right? So then what's next is we need to divide by N, which N was $C, $2, right? Let's see what's next. And we need to close this parenthesis, and then we would type the caret key, and then open parenthesis, negative. So I would do $C, $2 again for N, and then we have times, and then where's the time? That's in cell C6, right? But for kind of a similar reason why we locked in the column for the APR, I'm going to want to lock in the row for this value, right? So when I pull this down, I don't want the row to change, right? All of the years are in row 6. So I need to lock that in and then close two parentheses, right? So that should be the formula that we input. So let me type this in quickly so we could do equals, open parentheses, $A, $2, right? And we have times $B7 divided by $C, $2, close parenthesis, divided by, open parenthesis, 1 minus, parenthesis, 1 plus, $B7 divided by $C, $2, close parenthesis, and then exponent key, so shift 6, and then open parenthesis, negative, and we'd have $C, $2, times C, $6, and then 2 closing parentheses, right? Good. So if I hit enter, that should give us a value, right? And remember, if you ever get an output like this where it has these like hash marks, that means that your number's too big to show, right? So if we make that column wider, we can see the full value, right? So we can double check on the screenshot to make sure. So if you look back on page 9, right, if we look in the output and see 7 from the screenshot, that is the exact value that's shown, right? Good. So now we should be able to drag this down, and then also select this and drag it to the right, and we should get the payment function for all of those years, right? So if we just compare this with this screenshot, everything seems to match, right? Perfect, right? And it makes sense, right? Just thinking about this quantitatively, right? As I go down the column, I should be paying more, right? Because I'm paying more interest. I have to pay more to the bank, right? But as I move to the right, if I spread out the loan payment over years, right, my payment gets smaller, right? One thing we'll figure out is we end up paying more interest, obviously, because we're taking more time to pay back. But my payment is a smaller amount because I'm not trying to pay it back as quickly, right? So this table makes sense quantitatively also, right? Which is an important skill from this class, right? Being able to think about things quantitatively like that, right? So then the next question is number 7, right? It says how much total interest do you pay with the $289.99 monthly payment, right? So $289.99 is this box, cell G6, right? So I'm going to highlight this yellow, right? Just for reference. So we're asked how much total interest do I pay, right? So to figure this out, right, one thing you might want to think about is I'm paying this payment $289.99. Right, that's my monthly payment. Pay it every month, right? I'm paying that monthly payment over 5 years, right? So we would have to do times 5 times 12, right? This would be how many times you'd pay it total, right? 12 times a year, 5 years. So I'd have 60 payments of this $289.99, right? If I do this, if I multiply these together, this is going to give me the total amount paid, right? The total amount that I paid the bank, right? So if we just grab a calculator, right, and multiply this really quick. Oops. So 289.99 times 5 times 12. So I'm getting 17,399.4, right? I guess I could pull this up also, right? So we took 289.99 times 5 times 12, right? So that's the amount I'm getting, right? So then now though, what we want to do is we're asked the interest only, right? So let me write this amount down. So we had $17,399.40, right? But I want to know the interest. So if I take the total paid minus my principal, this is going to give me my interest, right? So in this case, I'd want to take the $17,399.40 and subtract off the $15,000, right? So if I do this, if I take off $15,000, right, then we get this amount. So let me write this down here. So we get $2,399.40, right? So this is the total amount of interest we pay, right? So then question 8 says, well, how much would you save if you switch from the 5-year 6% loan to a 5% APR, right? So we're keeping the same time, right? So we're just thinking if I switch from the 5-year 6%, right, which is the box I've highlighted, and I want to switch to a 6%, switch to a 5% APR, right? So that'd be just moving up one box, right? So in other words, I'm knocking it down just 1% each year, right? So that in the light green is what we want to compare, right? So we can certainly figure this out. So I already know that I would pay $17,399.40 total from the previous one. So then if I subtract off how much would I pay total if it was a 5% loan, then I could easily calculate that, right? So if I take away, so my monthly payment would be the light green, so the 283.07, and I want to multiply that times 60, right? And again, I want to multiply it times 60 because I'm doing 5 years, right? So that's from here. 5 times 12 is 60. So if I go back to my calculator and take 283.07 times 60, this would give me the amount that I would pay total if I had the 5% loan, right? So then if I take the 17,399.40 and subtract off this answer, right? So I'll just hit second answer. Hit equals. We get $415.20, right? So $415.20 is what I'm getting. Right? Alright, good. So if we go down to the next question, number 9, it says, how much would you save if you switch from a 5-year 6% loan to a 3-year 6% loan? So in other words, we're fixating the 6%, but we're switching from 5-year down to 3 years, right? So we're still doing this, the 5 year, so the yellow box, we're still using this, but we're going to compare it to 3-year 6%. So I'll highlight this in this light blue. Right? So we need to repeat something similar, right? So first of all, to figure out how much I would pay total with this blue box, right? I would just take the value 456.33 and multiply by 60, right? So we get $27,379.80, right? So that's how much I would pay total. Or no, not times 60. Sorry. Let me write this out so you can see why it's not 60, right? Because we're changing the years, right? So you'd want to take 456.33 times, and then we're doing 3 years, so it'd be 3 times 12, right? So 36, right? And immediately I knew that couldn't be right, because but when we multiply that 60, that number is way too high, right? Just using some quantitative reasoning skills, right? So it's important when you're working through problems to be able to recognize that, right? But, it's okay to question, like, is that number right? Is that number okay? Because everyone makes mistakes from time to time, and and it's important to be able to think through, right? That's a critical thinking skill that you need, right? And that's one thing this class is helping to develop. Right, so if we do this, right, let's see if we get a better value, right, which we should. So 456.33 times 3 and then times 12, we get $16,427.88, right? So this number seems a lot more reasonable, right? And remember our previous value, how much we paid total was this, right? So that's from the yellow box from the chart, right? The $289.99 payment, right? So if I'm paying over less years, right, it means I'm paying less interest, then I should be paying less back total, right? So since our number from our calculation is less than this, then we're in good shape, right? So this came out to be the $427.88, right? So again, we're trying to figure out how much would you save. So I need to subtract these two, right? So I need to take this $17,399.40 and subtract off what we just calculated, right? How much we'd pay total if we were doing the 3-year 6% loan. So if I take the $17,399.40 and subtract off the $16,427.88, then I'm getting $871.52. Right, so the solution 871.52. Right. Whoops, and sorry about that. I noticed I made another error up here, right? I accidentally typed in $17,299.40 when it should have been $17,399.40, right? So you guys might have been yelling at me on the screen as I was typing that in, right? So if we were doing this in the classroom, I'm sure someone would have corrected me. So I apologize for that. So let me calculate this, typing in the right values, right? So we had 16,427.88, right? So now if I hit enter, there we go. We're getting the right solution, right? So we were just I was 100 off. Actually, this should be 971, right? So that's how much we would save. Right? So then number 10 says if you have horrible credit, you might be forced to take out a 6-year 10% loan. How much interest do you pay over the life of this loan? Right? So and that's true, right? If you have bad credit, right, typically you don't get as good of a loan. You end up having to pay more, right? So if we look at 10% 6-year loan, we're talking about this value here, right? So the lease payment, it's the lease payment for the 10% option. So I'll put this in maybe like a light purple, right? So $277.89, right? So that's the number that we're working with. So the question is, how much interest are we paying, right? So if I take the payment $277.89 and I end up excuse me, if I take this and multiply times, so 6 years times 12, right? Then this calculation will tell me how much I pay total in the end, right? But we want to know the interest. So then what I need to do then is subtract off the principal, which is $15,000, right? So if I do this calculation, let me just bring up my calculator again, right? And again, being careful, hopefully not to make a typo. So we take $277.89 times 6 times 12, right? And we'll hit equals. So we end up paying $20,000, right? Which seems reasonable for these values. So then subtract off 15,000. We end up paying $5,000, over $5,000 in interest, right? $5,008.08. Right, so you can see that that's a lot of money paid in interest, right? You're paying nearly a third of what you borrowed back to the bank, back for interest, right? So then number 11 is just an exercise. So it says, what is fixed column or row by the following cell references, right? So it's just an exercise to help us reiterate the fact like when we want to fix or lock in a column or row when we reference cells. So in the first one, we have $sign in front of the F and the 4, so both are locked in, right? The next one, the $sign's in front of the 2, so that locks in the row, right? That's going to lock in the number 2, right? It's whatever the $sign is in front of, right? The next one is T1. There's no $sign, so this would be a neither, right? Neither one's locked in. The next one, the $sign is in front of the V, so this would be the column. And then in the next one, the $sign is in front of the 21, so this would be the row, right? And then lastly, the $sign is in front of the S, so this would be a column, right? Column, right? So that's just a good exercise, just to make sure we know the cell referencing, right? Because again, that's a big part of this class, and we're relying on that a lot to make these charts. All right. So it looks like that's the end of the worksheets for this lesson. So let me minimize the OneNote, and I'm going to go full screen with the Excel, right? So I do want to finish this Excel chart, right, with you. So remember when we do Excel assignments, the directions are in these the boxes, right, off to the side. So let's see if if we've been missing anything. So part A says recreate the 10x6 table computing the monthly payments for a $15,000 loan for the 10 different APRs and 6 different lengths of time. Be sure to use proper absolute mix and relative cell references, right? So we already did that, right? Okay, right? So then part B is asking us to create another table which computes the total interest paid over the life of the loan for each of the 60 monthly payments given in the table. There is a very easy way to do this, right? It says simply subtract the loan from the table of all the payments made over the life of the loan, right? So be sure to use proper absolute, mixed, and relative cell references, right? So we want to create a table that's able to calculate the total interest paid over the loan. Right, so before we were doing this very manually, but it would be very convenient if we could do this not so manually, right? So let's start by working in this column, right? So so what I would start with doing is doing equals, and then taking this cell C7, right? How much the payment is, right? And then we would want to multiply that times 12, right? For 12, because we're doing monthly payments, right? There's 12 payments in a year, right? So we're redoing the process that I was writing on the OneNote, right? So we would take the monthly payment times 12 and then times the years, right? So in our case, the years would be here in C6, right? Now, one thing you want to think about though is when I drag this formula, all my years are in a row, so I don't want this to move, right? The row. So I'm going to put a $sign in front of the 6, right? And I didn't need $signs with the C7 at all, because when I pull this up and down, left and right, I want the cell to move in this the table above, right? I want it to move freely. Depending on what direction I'm moving, right? And then I'm going to subtract off the principal, which would be $sign A, $2, right? If you remember, A2 was our principal, right? Up here in the top left. So then I could hit enter, right? So now what this is doing, this box is calculating how much interest that's been paid, right? So then if I drag this over and then now drag down, fill down, I can fill in the whole table, right? And it looks like I need to fix some column widths here. So I'm just double clicking in between the columns and it automatically adjusts to how big it needs to be, right? Alright, so now what I can do is take this and let's compare with with what we got before, right? So like number 9, right? We were comparing the or well, let's do number 8, right? So it says, how much would you save if you switched from the 5-year 6% loan to 5% APR, right? So now this is much easier to work with if we match up 5 years, 5 years at 6% interest, right? So I'll fill this in as yellow. That would be this box, right? So this box tells me how much interest am I going to pay over the loan, right? Because no matter what number of years or APR that you have, you're going to have to pay back $15,000, right? The principal, no matter what. So really what the difference is how much interest you end up paying, right? So we just we could just subtract their interest, right? So now if we compare that with the we want to compare that with 5% APR, but still 5 years, right? That would be this box, right? So I'll put that in blue, right? So then here, if I make another chart, right? So this would be comparing, or I'll just put, this would be number 8, right? So I'll just put number 8 for reference, right? So for number 8, what we would do is we equals and subtract these cells, right? So take the yellow, which is cell G26, minus the blue cell, and hit equals, and we get $415.41, right? Which notice though that that's a little bit different value than what we got from our calculation earlier, right? And you might wonder why, right? Why is that off a little bit, right? And the reason why this is off a little bit is if we go up, if we scroll up, excuse me, look at the first table, if, my best guess is that if I click on cell G12, right, which is the yellow, so this would have been the payment function for 5 years 6%. If I add more decimal places, look there, there's more decimal places than what has been shown, right, before, if we're just rounding to the nearest cent. So if I do the same thing up here, I would imagine there's something similar, right, which there is, right? In fact, it went down because Excel had to round up, right? So what's happening is when we go off these just dollar amounts, that's not an exact value, right? But Excel, when we use cell references, that's calculating the exact value, right? So, when you're using Excel, that's one main benefit, is we can always get exact values and not have to worry about rounding, right? You shouldn't round and then use that answer to round. That's going to have some rounding error, right? And in fact, the rounding error is addressed in the text, and something that we need to be aware of, right? It might not seem like a lot. It's just a matter of like 21 cents difference. But if you get like $1 million loan, that's going to be a lot of money that would be off, right? So doing things by hand, may not be the best way to go about things, right? So using Excel in this fashion could be a lot more convenient, right? So like, for example, if you want to do number 9 over again, right? So for number 9, we're going from the 5-year 6% still, right? So the yellow minus what we went 3-year 6%, right? So that would be this box, right? E26. So if I hit enter, I get $971.68, right? Which again is off from the answer we got for the same reason, right? So then I could go ahead and do number 10 really quick, right? Just to get exact answers. So I'd want to take, so here we're going, oh wait, no, so sorry, number 10 we're not comparing, right? We're just calculating the total interest. So the answer for number 10 would be whatever cell is in, wait, we want 6 years 10%, right? So H30, right? So again, that value is off a little bit, right? By 18 cents. So So these would be the exact solutions, right? Whatever's in Excel, right? All right, so that ends this video. As always, feel free to contact me if you have any questions. Thanks.